Okay, yesterday we were talking about different equations and relationship between traffic flow parameters. There are three main traffic flow parameters: flow rate, density, and speed. There is a basic equation between them, and then there were other equations for these three with headway and spacing and so on. Okay, we looked at some equations. There were some small examples in which we calculated different things. Okay, and then we looked at the different approaches of looking at the traffic flow. So we can have macroscopic approach or microscopic approach. In macroscopic approach, we look at the entire flow. In microscopic approach, we are looking at different vehicles. Okay, another name for microscopic is the car following theory. Because in microscopic, you are looking at how one car follows the other, or how one vehicle follows the other. So we call it the car following theory as well. Then in this course, we will be focusing on macroscopic approach. Okay, so we will look at the entire flow. For the macroscopic approach, there are two types of models which are given. Okay, one is by Greenshield and the other one is by Greenberg. So there is Greenshield and Greenberg. Everything is green. Okay, they were from Pakistan. The flag of Pakistan is green, so if there were other names, I just removed them. Okay, only greens are allowed. So the Greenshield model was the one which we have used in the traffic course. So I showed you some graphs, and there was a linear equation and so on and so forth. And Greenshield model is the one which is with a natural law. This one. Okay. And then we said that these two can be applied in different conditions. The Greenshield model and the Greenberg model. They can be applied, both of them can be applied to traffic data, but they give more accurate answers in different conditions. The Greenshield is more for light and dense traffic condition, but before the capacity, uncongested. And the Greenberg model, it works after the capacity when you are reaching the zero condition, the boundary conditions. Okay, so when you have extreme traffic, very high, very low, then the Greenberg model is better. It gives you better performance or more accurate results. Okay. Now let's say you have your own data, you want to build your own model. So the easiest approach, the most commonly used approach is that you do linear regression analysis for your model. What is a linear regression analysis? To come up with this equation. This is called as a linear regression equation. Okay, linear regression. Linear because it's linear, x single power, y single power. And regression means that regression basically means going up and down. Okay, like going back and forth. So something is moving forward, backward, backward. Okay, so your data is like this, right? Your data is like this. Some values are very high, some values are very low. So this is regression. This is what we call as regression. Okay. So that's why an equation to which can cover the high values and the low values, a regression equation. Okay. And how to make the regression equation? Y and x is my data. Y is the value I want to find out. X is the value which I will have. And A and B are constants. And for this equation, the constants can be calculated using these two equations. Okay, and I explained it yesterday as well. What is small y? Value you observe. What is small x? Observe. Okay, so there are two observed values, two observed parameters. And what is n? Number of observations. Okay, and I told you x and y observations should be equal. And what is this y dash and x dash? Average. Okay, average of y values, average of x values, And if you have the y and x values, why are you making an equation out of it? For other cases which are not part of your data. Okay. Now we are saying that this equation fits my data. We already seen two types of equation, right? One was linear, the other one is by Greenberg with the natural log. Okay. So how can I make sure that this equation actually fits my data? This equation is actually suitable for my data. How can I say this? Okay. So after I make the equation, after I get the value of a and b, I should have some test to see if this is the right equation. Okay, and that test or that parameter which is used for the test is called as R square. Okay, or coefficient of determination. R square or coefficient of determination. This is a value which you calculate to see what is the fit or relationship between the equation and the actual data. How close the equation results are to the actual data. Clear? Okay. So you had the data, you assume that I will make a linear regression equation out of it, and you made the equation by finding out the values of a and b. Then to make sure or to have confidence in your equation, I need to calculate R square. Okay. Now what is R square here? A small y you already know. Y dash you already know. Okay. We have capital Y here. Now R square is between what and what? Tell me. The actual and the calculated. The actual and the calculated. Okay. So small y is the actual and capital Y is calculated. Okay. Small y you already know that is actual. Capital Y is calculated. Okay. And y dash is the average. Okay. So R square it has a range between 0 and 1. It has a range between 0 and 1. Okay. 1 means good, 0 means bad. Right? Always, right? So if you get a value closer than 1, closer to 1, your equation is doing good. It is a good fit to the data. If you are getting an answer which is closer to 0, your equation is not good. And normally, if it is more than 0.6, acceptable. If it is more than 0.6, acceptable. Okay? Because to get 1, exactly 1, then it's very difficult to have a real world data and get R square equals to 1 exactly. It's very difficult. Normally it doesn't happen. Okay, you get something in 0.9, 0.8. It's considered very good. Okay, what does it mean? So for example, if R square is 1, okay, that means there is a 100% matching between the equation and the actual data. Okay, they are calling it correlation. Correlation or matching. How much is the matching between the equation and the actual data? So 1 means 100% matching. Okay, and 0.5 means 50% matching. 50% of the values are matching, 50% are not matching. Okay, or the equation is giving you answer up to the 50% of the actual data. So that's why more than 60% considered good. You know why? You know why? Sorry?
Because the 60%.
Yes. Okay, but below 60 is what? F. Okay. So not acceptable for you, not acceptable for them as well, right? Standard. See? Okay. Okay. Now, if you have to apply say green shield model. You are saying that my data will fit a green shield model. Okay. So you collected data from the field, data for speed and density. So speed is your y and density is your x. Okay. And then the green sheet model is this. The green sheet model is this one. Now I'm going to perform a linear regression for this data. Okay. The linear regression, if you go back, this is a linear regression. Right? So what I will find out? A and B, right? Look at the equation, tell me what is A here, what is B here. A is UF and B is
UF over KJ.
UF over KJ. Anything missing? Nice. Okay. So you will find out these parameters. Clear? Clear? Okay. So let me write the equations here, but I didn't bring the markers. Very good. Just write the equations first. Where? Write these two equations and I will go back to the slide. This is very simple, right? Average of y minus b into average of x. So I have to find out b first. Done. Wrote the equation, b equation. Wrote it? Okay. Okay. Give me the b value. Or give me summation and the average of these columns, just to make sure that we don't mess up in the end. We spend so much time. It's not correct. So give me the summation of both columns and the average of both columns, because we will need it.
For the X, 892. So the
And your average is 89. How many are there? 10?
14.
14?
For US 404.8.
Uh,
The summation was 404.8.
point?
And the average for the X is 63.71.
63 point
7
for y.
14 numbers. So
I is 40.
28.9.
And N is 14. Right? Okay, so give me B then. By the way, your calculators can make linear regression equation for you. They can give you the equations direct. You put these 14 values, and get the equation direct. But you don't know about it.
Depends on
What?
It's your job, it's your.
What?
It's your job. Go down now.
what's it in YouTube?
Yeah?
What's it in YouTube uploaded? We get a lot of views.
You know when did I last held a calculator in my hand?
Your
It
calculator
was
is
years
there.
ago.
Now you have your own calculator.
Hmm?
You use this calculator.
I know it's there.
ولا هاي المعادلة طلعها بالآخر مضمون بعدين كان دراسة في مواد
Your calculators can calculate average for you, standard deviation for you, percentile for you. But we don't know it, so we don't do it.
Where's that? No. Where what?
Mode 3 2.
Huh?
Just type mode 3 2 and you get the linear.
لا مو هذا مين شيء يصير تبع مين؟
المود 3.
No, they will not listen to you. They are happy together. Huh? He is telling you what to do.
مش عارف تو
ما قلت مود 5 2.
ما يكون ما سمعت
سمعت عليك.
Tell me whatever you do. Tell me be well.
Mode 3
Okay.
2.
مو
3 2.
مو ما طوفت
This will not be in the formula sheet. So by that time it may become mode 5.2 as well. You said, doctor, I am doing mode 5.2. Where is it? So difficult. Where is your mode 3.2? Man versus machine. Huh?
You need the steps also.
Which is steps?
You already have the submissions in it.
There will be only you can solve by equations.
Give me B, then we'll calculate A. A needs B. What? Ah, you need x into y as well, okay.
Yeah, that's good.
And x square as well.
The density gain. The average is the last thing here in the equation.
What? This is average density. And this
So
is
it's
average.
not K, not jam. It's the another K in the equation.
What do you mean?
I mean the last K on the right. This one is the
The last k will become x.
X average.
No, no, x. X.
That's it.
X will change.
You wait for it to see if you know or not.
What?
I got a negative.
Yeah.
It's good.
B is negative. B is negative. B, right?
Yeah,
B is negative.
I got negative 0.52.
So B is negative negative 0.528. Okay, then A. Why it is negative? Because this is negative, right? This is negative. The original linear regression equation has a positive sign. So whenever you have negative, you will have negative. How much? How much is A? Okay. Okay. Now tell me, this is A and B, this is the regression equation, right? But what does it mean here? We said A is what? UF. What was UF? What was UF? Free flow speed. So this is the free flow speed. Okay. What is B? UF upon Kj, right? Okay. So do I have any unknown here? What value I don't know? Kj. I can find out Kj
Yes.
because I already found UF. Okay. Now how much is Kj? So this is your B. B equals to UF upon Kj. You already know UF. You have to find out Kj. Okay.
A is two.
A is UF. Huh?
UF is
This is A. This is B, right?
A. Yeah.
So this is A. A is what? UF. This is B. B is what? UF upon Kj. So when you found A, you found UF. You have to find Kj. How much?
118.44.
What is Kj?
Jam density.
Jam density. So vehicles per mile. Now, how do I know what I did is correct? I have to calculate R square, right? Okay. Now, if I go to the equation for R square, you noted these values? Note it down. Note them down. If I move, they will be gone. Noted? Okay. Okay. This is R square now. Now, what do I don't know in this equation? Huh? Y capital I don't know. What is Y capital? Huh? Calculated value of Y, right? Calculate from where? From the equation. So I need to find out this Y value. Okay. So what will I do? I'll put K value in this equation. I already know all these parameters, right? So I will take k value in this equation, keep the rest of the parameters, and for each value of k, I will have a value of us. The us will become my capital Y. So first of all, you have to calculate for each value of k a value of y. Okay, give it to me.
What was the US this one 53.2?
Which one?
Already calculated.
It's the actual observed. Okay, this is small y. This one is small y. So for each value of k, I need a value of y. So I write it here or here, capital Y. So you already have UF, KJ. Give me the values of capital Y. Tell me. So just keep the equation, keep on changing the value of k. Yes.
44. 35.1. 31.9. 30.8.
20.8.
45.5. 25. 22.9.
19.2. 14.98.
9.7. 9.7. 1.79.
1.79.
Last one.
Okay, last one.
Last one, 1.7.
Okay, and the one before this?
9. The 100 is 9.7.
Yeah.
The 100 is 9.7. And this one, 90. Did miss any value?
14.9. Down? 14.9.
14.9 this one. Okay, how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Missing one. Which one? How much? No, for 90, how much is the value?
For 90, 14.9.
14.9. Then for 82,
For 64, it's 28.7. But you write it wrong.
That's 39.
metric is
44 is 39.
44 is what?
39.
Here?
No, the K 44.
Yeah, 44, 39.
39.
Okay, and this one is?
39.3.
No.
That one for
For 5 to how much is it?
44 because I'm missing one.
Yeah, I just want to confirm. For 5 to how much is it?
35.1.
35. So there is one missing here. 13, how much you say? So after 44, there's 39.2 and then the rest.
39.3.
Okay, now we need R square. Okay, this one is capital Y, and sorry, this one is small y, this one is capital Y. Okay, so here you will use these values, and here you will use the observed values. How much is R square?
So we can use the calculator, use this like a table or something.
Sorry,
We can use the calculator.
you can.
I know you can.
If you know how to.
Of course I can.
Don't ask me.
Ask them.
Uh-huh.
Don't ask them.
Casio. No, I think they have manual or something with the calculator.
I'll check it with you.
Huh?
I'll check it with you.
Sure, no problem.
If you want to use Excel like now.
Uh-huh.
You want to use Excel like now.
Hmm?
The exam less values.
Maybe. Or more values. Who was with me in traffic last semester? You were there, right?
Yeah.
One question, right? I gave one question.
Yeah, the exam will come question like this.
More value. Extra value.
By that time you will know what to do with the calculator,
Yeah,
right?
of course.
50 values. 50.
That,
What
I'm
5
seeing
0
it.
Vector? No 5 0. ما فهمت الآن.
Huh?
Vector. No YouTube can record. You will not record lectures on YouTube.
I'm recording. Yeah. Everything you are saying is being recorded. And later on I will see what you guys talking about in Arabic.
You will translate.
Huh?
You will translate everything.
Next time I will put my laptop there.
why me?
Huh?
Why me? There, why me?
I like you.
I like it.
Vector really they are from Pakistan.
Sorry.
Really Greenshield is from Pakistan.
Come on.
The name is not Pakistan. Greenshield.
So
Maybe it's from Scotland.
So even if you keep on talking, you can do it in how many minutes? Half an hour.
That means the other exam is come with only one question.
Huh? Maybe. Okay. So is it good or bad? Tell me. It's good, right? So what do you mean by what do you mean by 0.87? What does it mean? Yeah, the values are matching with the equation by 87%. Okay. Now you use these values to find out the equation, right? Exact same values to find out the equation. Okay, but still you did not get 100% match. You did not get 100% match. Why? Because the real world data, like I said, it's regression going up and down, back and forth. Okay, so the equation is trying to balance. This method, regression method, is trying to balance that when the data goes up, the value of the equation should also go up. When the data goes down, the value of the equation should also go down. But in trying to balance, because the real world data is random, it's not following the equation. So when you try to fit an equation to a random data, then it will cover the data but not completely. Okay, it will cover the data, not completely. It's like you have loose sand and then you try to put it in a box. Okay, so the box has a specific shape, right? But the sand itself is loose. So some of the sand, if you try to fill the box, some of the sand may go out of the box, right? Okay, same thing. The equation is your box, which has a specific shape, but the data does not follow this shape. Okay, so this is what I was saying, that you may not fit the data, completely. Okay, but this one is good. 187 is good enough value. What was the limit? 0.6, right? You will not forget it, right?
Yeah.
You forget it, you might get it. Okay, so now we have a simpler problem. The model is given, okay, US equals to blah blah blah, and you have to find out the following: mean free flow speed, mean free flow speed, jam density at maximum flow, speed at maximum flow, and what is the maximum flow rate, the capacity. Okay, first of all, mean free speed. You made this equation, right? Where is the mean free speed? Free flow speed, where is it? Huh? You have right? Okay. The first parameter. So the mean free speed is how much?
62.
60. Okay. Then we need jam density. What was jam? Where was jam density here?
No.
Where was jam density? The equation was US equals UF. This was the equation, right? Okay. So where is jam density? Kj. Now how do I find out Kj?
I have
0.51 equals to what?
62 over kg.
Yeah. UF upon Kj. And you already know UF. Okay, how much is this? How much is it?
121.6.
Okay. Now we have to find out density at maximum flow rate. Do I have flow rate here? Do I have flow rate here? I don't have, right? There is no flow rate here. So from this equation I cannot find it. Okay? I have to come up with some other equation. There was an equation which I showed you last time, which was Q equals U into K. Flow equals speed into density. Okay? So I have to use this equation now. Now what is my problem here? My problem is to find out
maximum.
where is maximum flow. Okay? The graph between density and maximum flow was something like this. Okay, this is density, this is this. Sorry? Yes, for fun. It's per lane by default. Default per lane. Huh? No problem. The default is per lane. These things are per lane. This is the default. Okay. All these things are done for one lane. All these equations are done for one lane. Because if there are multiple lanes, then you have to. Did you see number of lanes here somewhere in the equation? Multiply by number of lanes. You did not, right? So by default, they are for one lane. Okay. So if I put the per lane, I don't put the per lane, but the default is what? Per lane. Okay. Okay. So I want density at maximum flow. So I need an equation between density and flow, right? I need an equation between density and flow. Okay. So what equations do I have? I have this equation and I have this one. Okay. Now I want to replace what? I want equation between density and flow. I have to replace U. Okay. So it will be K upon Q upon K 62 minus 0.151. Okay. And then Q equals to what? 62 K minus 0.51
K Q square.
Okay? Not okay? equation, I want to find out what is u. So u equals to what? Q upon
Okay.
k. So I take q upon k and put it as u. So this is the equation I get. So I take q on one side, everything else on the other side. Clear? Everybody, clear? Okay. Where is the maximum flow there? In the middle. In the middle? Where is the middle? When what happens? When you get the maximum point, what happens? To the curve.
لا شجعهم capacity يعني في البداية
Huh? No, when you reach maximum flow, what happens to the curve? No, at that point what happens? Slope becomes zero. See, the curve is now, the slope is horizontal. That means zero. Okay. So this is my equation. I'll make the slope zero. So d2 upon dk. Okay, so it will be 62 minus 0.151 into 2 k equals 0. Slope equals 0, right? Slope equals 0. So what is k now? How much?
61.78.
So this is the density when slope becomes 0. When does the slope become 0? When the q is maximum. So this is the density when you have maximum flow. Clear? Clear? Okay.
Exactly the half of the jam.
Exactly the half of the jam. Okay. Now, one more thing which I can find out. In fact, I can find out the other two without any derivation. I don't need any derivation. How do I find out this one? Speed at maximum flow. What should it be? Half. Who told you it's half? Who told you it's half? Sorry, say again.
Maximum flow.
When you have maximum flow, then you have what? Which value do you have at maximum flow? It's not maximum density, it's density at maximum flow. It's density at maximum flow. You want what now? Speed at maximum flow. Do you have an equation between density and speed? Come on, it's given. Okay, so if you have maximum flow, then density equals to this and speed equals to, then you put the density value in the equation. Okay. How much is it? 31? Okay, now maximum flow. The last thing is maximum flow. What is maximum flow? What is maximum flow?
Q equal U times K.
Huh?
U.
Yeah, you already know
You already know K and you know
the K and the U. What was the U?
U 31.
31. So you can you put these two equations in this equation, it will give you maximum flow. Or
And 8 4
yeah, but you can do one more thing. Or there's another option to calculate maximum flow, which is from there. Which other equation can give you maximum flow?
Only from K.
From K. Okay, you have this equation between K and density, Q and density, right? So now you already find out density. You can put density over there and find out. In both cases, you will get the same answer. Okay, so how much was Q in this case? Maximum Q. So we have 31 multiplied by 60.78, and you are saying it's 188.
188.
Clear? Any questions?
So if we point something, we need to
Huh?
we approximate.
How much is it?
188 or 120.
0.18. Okay, you note it down somewhere. 0.18. Okay. The next time you get a number, again note it down. Keep on noting it down. At the end of the semester, we will add all these numbers, and then you see how many cars we have, and then you will give me those cars. Okay. It doesn't matter. 0.1 there, it doesn't matter. Okay. When you will mess up, you will not mess up by 0.18. I know. Okay, anything else? Clear? Okay, thank you. Somebody is studying, huh?
Just a small one.